So you'll have just carried out a practical, hopefully, and it's investigating the oxidizing power of halogens. If you asked for proof of oxidizing power of the halogens, you need, this is the go-to experiment. It's the halogen displacement reaction experiment. So in a nutshell, this is what you did. You had 6 test tubes. In 2 of them you had a solution of sodium chloride, 2 of them you had sodium bromide, and 2 of them you had sodium iodide. Now you can use any halide solutions because the metal is just a spectator, so you could use any. Now what you then did is added a dissolved halogen of the other halogens in the group. So there was no point in adding dissolved chlorine because there wouldn't be any reaction. So what you would have added would have been bromine solution and iodine solution. You would have added to sodium bromide, you would have had chlorine solution or chlorine water, and you would have added iodine water, iodine solution. To the sodium iodide you would have added chlorine solution and then bromine solution. The observations made, for the first one you would have seen no reaction. So what that means is that the bromine would not have been able to displace the chlorine. So in terms of reactivity, bromine would be less reactive than chlorine. Iodine, exactly the same, no reaction, no visible change. So the iodine is not able to displace the chlorine because it's less reactive. The next one, the sodium bromide, the chlorine would have displaced the bromine, or the bromide, sorry, and what you would have seen would be the bromine being released into the solution. So this would have turned yellow. The iodide is not reactive enough to displace the bromine, so this one you would have seen no visible change. The last one, sodium iodide solutions, adding chlorine, this would have turned brown because the chlorine, being more reactive than iodide, would have displaced it. So would the bromine, because it's more reactive than the iodine, so this would have turned into a brown solution as well.